Hey everyone, we're going to look at number 7 in section 4.1, and we're going to consider the function f of x is the square root of x minus 4. We're going to determine the linearization. Okay, what is that? Linearization of the function f at a equal 20. Okay, express all numbers in exact form, right? So in other words, no decimal approximations. Okay, you want to give exact values. All right, so what is the linearization? Well, the linearization of the function is L of x, which is equal to this. Now, you can memorize this formula, but what's going on here? Well, real important, linearization is just the line tangent to the function at x equal a. This is just the equation of the tangent line. It's all we're doing. So when you hear linearization, automatically you're just finding the equation of the tangent line, which is what we've been doing a bunch of in chapter 3. So notice the point given is a comma f of a, right? At a, of course, in this case, a is 20, but in general, it'd be a comma f of a. And what's the slope? The slope is going to be the derivative of the function at a, right? And so, here's my regular equation of a line, y minus y1 equals m slope times x minus x1. So y1 is f of a, right? So I replace that there. M is f prime of a, x1 is a, right? And there it is. If I add f of a to both sides of this equation, I get this. And take a look at this, compare it to that. It's the same thing, right? So you're basically just finding the equation of the tangent line. Okay, so in this particular problem, we'll need, of course, a is 20. So I need f of a, or f of 20. What is f of 20? I'll just plug 20 into for x here. 20 minus 4 is 16. Square root of 16 is 4. So that's easy enough. And then when I look at the function, I'm going to need the derivative. I would rewrite, of course, f of x, the square root of x to the x minus 4 as x minus 4 to the 1/2 power. All right. So when I take the derivative, it's noticed by the chain rule, essentially, because I got a composition of two functions, inner function is x minus 4, outer function is u to the 1/2. So I bring the 1/2 down, the derivative of the outer function is power rule, bring the 1/2 down, subtract 1 from the power, right? Evaluate the inner function, times the derivative of the inner function. Well, the derivative of x minus 4 is just 1. So it doesn't really change much. It's just really 1/2 times this, which I can rewrite as 1 divided by 2, right? 1/2 is 1 divided by 2 times x minus 4 to the positive 1/2 down here, which is the same thing as the square root of x minus 4. So there's my derivative. I'm supposed to evaluate it at 20. And so when I plug in 20, I get the square root of 16, or 4, and that gives me 1/8. So if I just plug in these values, f of a is 4, f of 20 is 4. All right, so plugging in there, times plus f prime of a is 1/8, x minus a is 20 again. And so there it is. Now, if I clean this up a little bit, distribute the 1/8 through, 1/8 times 20 is 28, or simplifies to 5/2. And then 4 minus 5/2 is 3/2. And so there is the linearization. I think in the problem, they just want you to enter in that part of it. They give you the L of x there. But this is the linearization. Basically, again, if you just say y is equal to 1/8 x plus 3/2, that's the equation of the tangent line to that point. Okay, so not much really going on. It's just finding the equation of the tangent line here. When you hear linearization, that's what you should do. Okay, hope this is helpful.